Hi guys, Mario here. So today I want to talk to you guys about viruses, virulence, epidemiology was my favorite topic in college. But first,
Hi, let's take that off because now I can hear you guys and now I can see you guys. So, as I was saying, I want to talk to you guys about viruses, virulence, epidemiology. It was one of my favorite things in college. But before I even do that, I want to show you guys something else that was really kind of neat. Last night was the Grammys, and we all saw our friends walking in as visions in red. They were beautiful. And I even had to send a text message to my friend and be like, dude, why are you on my wavelength? Because as you can see, red is the color of the season. Okay, so now that that's out of the way, I want to talk to you guys about actual epidemiology and immunology and all that stuff. And so it's really interesting. It's a real fascinating topic. We all are very well aware that when you get sick, you create antibodies. And the antibodies that you create after being sick prevent you from getting sick again. And unless you have something genetically wrong with you, in which case then you can't produce antibodies and then you're always sick and you live in a bubble. Side note. Now, when we create naturally made antibodies, we're not going to get the same flu over again. And oftentimes, we can even pass these on to our children because it changes our genetic makeup. It also changes what our secretions, because when mothers breastfeed, they pass on some of these antibodies to their children because their children aren't born with them, so they pass them on through the breast milk. Now, when we start talking about man-made vaccines, some man-made vaccines are good and they prevent us from actually having to go through the suffering of being sick in order to obtain that antibody. Measles, mumps, rubella, polio, smallpox, great examples. They are all childhood diseases that oftentimes left the person with more handicaps than actually killing them in some cases. So even our own president, Franklin Roosevelt, was affected by polio and actually got put in a wheelchair. Granted, you didn't die, and granted, you can never get polio again, but now you're paralyzed. So some cases, our man-made vaccines are actually a benefit. And in other cases, like when it comes to influenza, they're a shot in the dark. Influenza and coronaviruses are two viruses that affect us most often. I'm going to talk about influenza first, then I'm going to talk about coronavirus. Influenza is one that we've studied a lot. We can recognize two specific markers, the H marker and the N marker, and their possible variations and their possible combinations. The H has 11 different variations and the N has 16 variations. So if you can take 11 different numbers and 16 different numbers and combine them in all kinds of different ways, that's going to be what makes an influenza virus. Now, some of those combinations we see on average. Some of them we don't, because some of them are only carried by animals. But when humans live very, very close to animals, like they do in Wuhan and in some of these other underdeveloped nations, these people are living literally side by side with their animals, and in some cases living with their animals, especially during the winter when they want to keep cold and they want to save money, because you're not going to be putting a heater out in the barn. You're going to bring the animals into your house. So you're living in close proximity to them, and then you have this culture, these cultures, and I say plural because it's not just China. Every culture does it. Every culture eats different types of animals and different types of creatures, and when you start consuming these creatures, you are exposing yourself again to pathogens, and that's what they really are. Is they're pathogens. They're looking to infect us as a host so that they can spread themselves. Influenza does this just the same way as coronavirus. It's not even a real cell. It's a mass of cells that DNA that connects itself to a cell and pumps its DNA inside of that cell and turns that cell into a replication center. Every single virus does this. It's then our CDC's job to say, okay, well, I haven't seen this one in a while, I haven't seen this one in a while, I haven't seen this one in a while. Let's go ahead and let's make a cocktail of maybe one or two of these. And we'll just say that this is going to be the flu shot of the season. Well, they're only right about 26% of the time. So of the 74% of the time, it's not even the combination that they created. It was some other random combination, which is why the flu shot isn't as effective. Now, combine the idea that the flu shot is losing its effectiveness because it's a shot in the dark, and it's never really had a huge effectiveness because, again, we are seeing more and more of these permutations, combinations, and mutations within the influenza virus, and you combine that with a 90% vaccination rate in China, these people never had a chance to develop their own antibodies. They've had their antibodies given to them by the Chinese government. So when bird flu breaks out, when swine flu breaks out, when SARS breaks out, they have literally no choice but to be relegated to their home and quarantined because they have no protections. In America, I would say I can't even tell you how many people don't get the flu shot because they know, I don't really want it, it makes me sick, whatever their reason. But then again, American diseases don't spread like they do in China because A, we've got clean water and we've got clean roads. We're not living next to animals like they are. So our possibility of infection is much lower. But our possibility of infection goes up when people go to work and they're sick, they're sneezing, they're coughing, they're wiping their face, they're wiping their nose, they're wiping their eyes. The people forget that your eyes have a mucous membrane and you are spreading contact with other people, those mucuses and those viruses that could potentially be present in those membranes, which is where they like to live. Now, coronavirus specifically is slightly different from a influenza virus, but it's still a virus nonetheless. Coronaviruses get their name because around the capsule that encases their DNA, they have little spikes, which make the whole thing look like a crown from the top. The coronavirus is then identified by the length of the spikes, by the width of the spikes, and by the curvature of the spikes. Those then tells us, okay, well, this is this type, this is this type, this is this type. But regardless of what type it is, it still works the same. It tries to get into your DNA and tries to turn your body into a processing center for more of its kind. Stay home, get lots of rest, and if you feel sick and you can't seem to get better, go see your doctor. Please. We don't want to see more people die. I don't want to have to wear this every time I go out. I will see you guys later.